How many students do we have right now? We have 9 students. One. Who is this? Give me a couple of seconds, please. One, two, three, four, five, six.
I'm preparing the things here.
So that must be Mark, right? That must be Mark. So
Yes.
we all know, or you all know, that we are going to have a quiz today, right? So the quiz will be composed
Yes.
of lessons from our previous lessons, specifically uh, last Wednesday, right? About the terms, and then I also included some of which is actually about the it's all about algebraic expressions, the integer, something like that, the
Yes.
multiplication and division of integers, the addition and subtraction of integers. So all in all, we have a 30 items test. Okay, so let me have it first. We're going to have the test. Anytime I'm going to share that one, okay? I'm going to share that one and paste it on the GC so that we can take the test. But for now, I am simply going to, okay, this one. So again, this is actually a 30 points or 30 points quiz, okay? Composed of um, finding the terms as well as listing all the terms in an algebraic expression, as well as it was all about integers, addition, subtraction, division, and multiplication of integers. Okay, so if you are all ready, are you all ready to take the test or not yet?
Mm, yes.
Yes, yes, yo. Okay, let me paste it on the chat
I'm
now.
on my camera finally.
Okay, very good. Okay, so again, I will have to ask each and every one of you to please open your camera. Please open your camera. Okay, so I already pasted it on the chat box. And then after 30 minutes, we are going to stop our quiz, right? Because we still have to discuss some of the items or some of the lessons regarding algebraic expressions. Okay, you may now start taking the quiz. I think you already saw the quiz, right? So
Yes.
if you are going to ask something, just call my name. I will be here only.
After 30 minutes, do we answer the question? I mean,
No, after 30 minutes, all of you must be able to finish the quiz. It's a very easy quiz. It's only 30 items. You can answer each item for 1 minute, right?
right.
Okay. Okay,
I'm nervous.
almost all of the quiz, you need to write the answer. You need to write the answer.
Miss Samirah,
Yes, Mark.
I'm currently on number 4. Wait. It is number 4 of list all the terms in each algebraic expression.
Okay. So what about it, Mark?
So I see that in number 4 there's square y square off, and I cannot write it. Y 2
Okay.
doesn't make sense. How?
Only need to copy it.
There's Miss Amira. I
Yes,
wonder
you're welcome.
how did Miss Amira can write y and square on number 4 list of terms.
Okay.
I'm done, miss.
Okay, Tristan. I received 4 responses already. Mm-hmm. Okay. Okay, for now, the highest score is 25, but I will have to check this one since when you list all the terms that we find on the algebraic expression, it is not the way how I wrote it. So I will have to double check that one first before I will be able to give you the scores. Okay? So we are still, I only received 4 responses. So we will still wait for the others. I think 5 responses. We're still going to wait for 5 responses. 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8, 9. So we're still waiting for 5 responses. Okay? We still have 4 minutes, okay? Okay, I've been talking and yet I forgot that I actually turned off the audio. So as I was saying, after all of you will be able to submit your responses, we will continue with our with our lessons. It is all about algebraic expressions. Okay? So we're still waiting for the others to submit their responses, okay?
How many minutes left, Miss Samirah?
Actually, it's overdone now. So we're still waiting for the others to come. I received 6 responses, or we're still waiting for the 3 responses. Okay, so I hope you will be finished soon because we will start with our lesson. We will continue with our lesson. Okay. So while we are waiting for the others to finish their responses, who can still remember uh, the meaning of what they call this one, variable? What does a variable represents with? Does it represented by a number, a letter, a symbol, or what? How about a constant? What is a constant? Do you know what is a constant? How about coefficient? Coefficient is what? And then how about terms? Do you know what does it mean about terms? So we need to know more about that one so that we can be able to evaluate, okay? Evaluate algebraic expressions, okay? Algebraic equation, I mean. cannot evaluate algebraic expression, but we can be able to evaluate algebraic equation. The difference, what is the difference between algebraic expression and algebraic equation? Right? 1, 2, 3, 4, 5, 6, 7. So two more. We're still waiting for two more. So there are actually two who got 25 over 30. Two who got 22 over 30. Three who got 22 over 30. One who got 21 over 30. Okay. So two more responses. I received 7 responses. So we're still waiting for the responses of Rayhan and Mark. Are you done, Mark?
No, I'm not.
Not yet. So Mark is not yet done. So 2, 4, 6, 8. So one more response and that would be Mark. One more response and that would be Mark. Rayhana is not with you, right? She's absent today. Okay, okay. So Alfonso cannot be able to take the exam or the quiz because he is in church. He's attending the church. Okay. Okay, I think it would be better if I will start sharing you the lesson. Lesson for today is all about algebraic expressions, etc., etc. Algebraic expression. Look at that. Can you see it now? So what is algebraic expression? We all know that an algebraic expression is a number or a combination of numbers connected by the symbols of operation. What are the symbols of operation? Addition, subtraction, multiplication, and division. It is actually called an algebraic expression. Okay. What are the examples of algebraic expression? Negative 3x, 2x, negative 3 over 5x. Okay. What are those 3, 2, and 3 over 5? These are all constants. Okay. And the letters such as the x or the y or the z are called variables. Okay. So the constants is actually the numbers that you can see before the variable. The variables are represented by a letter. So we are not going to limit ourselves with only x. We can also use y, z, a, b. Actually, all of the letters in the alphabet, we can use that one and make it our variables. The several parts are called terms. So this is negative 3x is one term, 2x is one term, and negative 3 over x is actually another term. Okay? The signs plus and minus connect the different terms, or addition and subtraction connect the different terms, or in other words, positive and negative connect the different terms. Okay? So 2x and negative 3y are terms of the expressions 2x minus 3y. 2x minus 3y. By the way, we can also say that negative 3 here beside the x is what we call coefficient. coefficient. A coefficient is actually a number. It is actually a number before the variable. Okay, or it is a number together with the variable. So that is what you call coefficient. So what are monomial, binomial, and trinomial? These are terms actually. An expression having only one term is called monomial. For example, negative 3x is one term and that is called monomial. Negative 4y is 1/3 and that is called monomial. 2/3 or 2/3yz are monomials also. Okay? How about binomial? How about binomial? Binomial is an expression having two terms. Binomial is an expression having two terms. For example, negative 2x minus 3y. That is actually binomial. Or 4x plus 5xz is also called binomial. How about those terms having three terms? An expression having three terms is what we call trinomial. From the word three, it is called trinomial. What are the examples? Negative 3p plus q minus 2/5pq is a trinomial. Or 7a minus 2abc minus 2c, something like that, that would be trinomial. So we are talking about, okay, we are talking about three terms. How about this one? What are like and unlike terms? What are like and unlike terms? Terms having combinations of literal numbers are called like terms. Terms do not have same combinations of literal numbers are called unlike terms. Okay. Literal numbers having same combination is like terms. Have same combinations of literal numbers. A combinations of different terms is called unlike terms. What are the examples? 4ab minus 3ba is considered as like terms. Why? Because of the presence of the variables a and b. Okay, this is called like terms. How about 3xy and negative 5ya? Negative 5ya. Can you see the same variables that you can see from 3xy to 5ya? You can only see that there is this same variable such as the y, but the x and the a is not actually the same. Therefore, we consider that one as unlike terms. We consider that one as unlike terms. Another one, 6abc and negative 5acd is also called as unlike terms. It is also called as unlike terms. While 8pq and negative 3qp is also considered as like terms. It is also considered as like terms. How about, okay, how about x squared and x? Can you consider that one as like terms? X squared and x. Can you consider that one as like terms? Can we be able to combine that one? Anyone? If you can see an expression having an expression such as x squared and x, can we be able to combine it and maybe we can add it or subtract it? What do you think? Take note, the order is actually different. X squared is actually in the second degree, while x is actually in the first degree. Okay? It is actually in the first degree. So what is multiplication of algebraic expressions? What is multiplications of algebraic expression? So the multiplication of algebraic expressions is the product of two numbers of like sign is positive and the product of two numbers of unlike sign is negative. We already know that one before. When we talk about the integers, if you are going to multiply two same sign, may it be positive, positive or negative, negative, we will be able to arrive to a positive result. But we are going to multiply a negative and a positive or a positive and a negative, that would give us negative sign, or we call that one as negative and positive is what we call unlike sign. So it will make a product of a negative integer. What are the examples? You know this one already. 3 times 5, take note. Without a sign, if we see a variable, a constant without a sign, or it can be a variable without a sign, it is actually considered as positive. But if we can see a minus sign, or we call that one as a negative sign, that would be, or a subtraction sign, that would be a negative sign. Okay? So we do not usually write the sign if it is actually a positive number or a positive integer. But do not forget, when we talk about negative number, we need to write the negative sign. Okay, look at this. Multiplying two numbers, which is actually two positive numbers, 3 times 5, it is a result. A result is 15, a positive 15. While if we are going to divide, if we are going to divide negative 4 over 5 times negative 5 over 3, that would give us a positive result or a positive answer because it is a product of two same sign. Another one is a negative 4 times 2 or a positive 2 would give us negative 8. And then 3 times negative 4 over 3, another thing with which it is talking about two different sign integers, it would also give us a negative sign. Okay? It would also give us a negative sign. So in the law of the exponent, a times a, okay. So I have here before, a raised to m times a raised to n, that would give us a raised to m plus n. For example, a squared times a cubed. A squared times a cubed. Who can give me the answer? A squared and a cubed. Who can give me the answer? We are talking about laws of exponents here. And specifically, that would be a product rule. That would be a product rule. So what would be the answer if we are going to multiply a squared times a cubed? Anyone? Anyone knows?
Very confused.
What would be the, No, walang mango. Anyone knows what is the answer? Thank you. Ano yan, Sarah? Tingnan yan. Okay. Anyone who would like to give us an answer for that? A squared times a cubed. I think I heard someone. What is your answer? I think it was Inda. Inda, do you know the answer for this one? A squared times a cubed. Sorry, Sarah. What would be your answer? Please start. Okay. Let me have it like this. I think I have it before. I'm talking about the laws of exponent here. Okay, wait. How about if I'm going to say x raised to the power of 0? What will be our answer? Anyone? A raised to the power of 0. What would be your answer? Can you still remember? We discussed this one before, but I think you forget again. Okay, look at this. So this is actually the rules or the laws of exponent. Look at this. This is actually the laws of exponent. This one. Oops. Okay. Look at that. So product rule, this is what I am actually telling you. A raised to the power of n times A raised to the power of n is equals to A raised to the power of m plus n. So if I am going to assign a number for m which is 2 and the number for n is 3, what would be your answer? What would be your answer? You only need to add all the exponent. We are talking about product rule. Noel, what would be our answer if you are going to multiply a squared times a cubed? What will be your answer? This is actually the pattern. We are going to add all the exponents. What are the exponents, by the way? From a squared times a cubed. What are the exponents?
2 and 3.
2 and 3. Very good. If I am going to add 2 and 3, what would it give me?
5.
5. So what will be your answer if you are going to multiply a squared times a cubed?
A5.
A to the power of 5.
A to
Very
the power
good.
of
That
5.
would be A to the power of 5. Okay, how about this one? We are talking about quotient rule. We are talking about quotient rule. The pattern is A raised to the power of m divide A raised to the power of n. What we are going to do with the exponent is that for the product rule, we added all the exponent, but for the quotient rule, we are going to subtract the exponent. Take note, for the quotient rule, we are going to subtract all the exponent. Okay, for example, a raised to m divide a raised to n. I will assign a number for m which is 5 and the number for n is 2. So a raised to the power of 5 divide a raised to the power of 2, what would it give me? You only need, take note, you only need to subtract all the exponents. A raised to the power of 5 divide a raised to the power of 2. What would be our answer?
I'm so confused.
Simply subtract all the exponents, Mark. The exponents are 5 and 2. You need to only subtract the 2 from 5. What would it give you? 5 minus 2.
3.
5 minus
5
2.
minus 2 is 4.
Are you sure 5 minus 2 is 4?
5 minus 2?
Yes.
5 minus 2 equals 4. I have this finger. 1, 2, 3.
5 minus 2
I'm super
again.
confused.
Okay, Tristan, what is 5 minus 2? 5. We're going to
3.
subtract 2 from 5. 3. Okay. So what would be your answer? A raised to the power of? What is your answer again, Tristan? 5 minus 2?
3.
Okay, very good. So that your answer would become a raised to the power of 3, or in other words, you can also say a cubed. The answer would be a cubed. Okay? So we will simply discuss these two rules, the product rule and the quotient rule. Okay, I will have to give you an example and then you will have to give me the answer. Okay, how about this one? Let me choose a color. Okay, this one. I'm talking about a product rule here. So x raised to the power of 5 times, okay, times, or take note, I can also write times as a simple, as a small dot, okay? As a small dot, such as like this, or as a small circle like this. And then ax times x raised to the power of 5 times x raised to the power of 4. What would it give us? Look at the product rule. What would it give us? For the product rule, you look at the base. The base is actually the variable x. If you look at it, you can simply add all the exponents. So 5 plus 4 would give me what? 5 plus 4? Huh?
X it's equal 6 plus n.
Okay.
I mean 6 plus 4.
X raised to the power
X.
of 5 plus 4. What would it give you? X raised to the power of 4 plus 5. Or 5 plus 4.
5 plus 4 equals 9.
Plus what? What is 5 plus 4 again, Mark?
9.
9. So our answer would be x to the power of 9. I hope it looks like a 9. X raised to the power of 9.
It looks like G.
Okay,
It's
next.
not like a G. It's
Not a,
flat narrow for
okay,
me.
let me read that one. X raised to the power of, oops, I think this course, this mouse is actually dancing. Wait a minute. X raised to the power of, oops, not really working. Let me try to place it on.
That looks like Chinese. Congratulations, Miss Samirah. Just write Chinese word.
I'm writing a
It's
Chinese
more
word.
advanced.
Okay. Wait. I cannot see the cursor actually. This one. Okay, that one. It's close to 9. That would be our answer. Okay, how about this one?
It looks like water drops today. It looks like water drops. Or a tadpole. Something like that.
X to the power of 6 times, okay, x to the power of 2. That one. What will be your answer? Look at the base. They are the same. They are like terms.
X, what is it? X with the power of 6 times X with the power of 2 equals X.
X to the power of?
The power of, is that 8?
Add. You are going to add the 6 and the 2. What will it give you?
8.
Add 6. Okay, the answer would be x to the power of 8. It's very easy
X
as
with the
long
power
as,
of 8.
yeah, you only need to look at the base. If you see that the base is the same, what you are going to do with the exponent is that you are going to add all the exponent. Considering that you are actually multiplying the base as well as the exponent here. So since you are multiplying the base, what you are going to do with the exponent is that you are going to simply add all the exponent. As long as you meet the criteria wherein you can see that the exponents are just the same. I mean the variable is just the same. The base or the variable is the same. How about if there is a coefficient at the beginning of the variable? So if you see a coefficient beside the variable, you simply need to do the multiplication thing with the number. Take note, if you cannot see any number beside the variable, that means it is 1. So if I have here 2x raised to the power of 5 times x raised to the power of 4, what would be your answer for that one? 2x raised to the power of 5 times x raised to the power of 4, what will be your answer? You only need to multiply the 2 and the 1, and that would give you 2. And then the same with the exponent, you are also going to add all the exponents. Okay, so we will continue with this one next meeting. I hope you will be able to master this one so that we can continue with the evaluation of algebraic equation. Okay, so do you have some questions? Do you still have some questions? Anyone? Do you still have some?
For the next meeting. For the next meeting,
Yes.
what do we learn? What do we learn for the next meeting?
We're still going to continue with the lesson, the algebraic expression, until we will be able to solve or to solve all the algebraic equations. Okay? Look at Mark's eyes. Okay. Do you still have some